Hi, everybody. Here we are at Hogwarts, and I'm about to start section 112 in number theory. So let's jump right in. So here we go. This is about the highest power of a prime p contained in n factorial. Now, the book goes through a whole bunch of fancy stuff. I want to just give you an example, and if you see the example, you'll have a much better idea of what's going on with what the textbook is talking about. So let's just go over here. Let's say so first of all, what is a factorial? So factorial, 10 factorial, for example, is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down to the end. And 20 factorial is 20 times 19 times 18, times 3 times 2 times 1. So suppose I would have the number 1,000 factorial. Now, 1,000 factorial is 1,000, and I'm just going to write this. Let me just write this explicitly. That's equal to 1,000, times 999 times 998 times times 3 times 2 times 1. That's a so it's multiplying the first 1,000 numbers like this. So how many zeros will this end in? Obviously, it's going to end in a zero. At the very least, it's going to be 3 zeros here because you're multiplying it by 1,000. How many zeros total are there going to be? Well, we have to analyze, where do the zeros come from? Well, the zeros come from the 2s and the 5s. Every time I multiply a 2 and a 5, I get a 0. Well, how many 5s are there? Let's just start with 5s. How many 5s are there from 1 to 1,000? If I look at all the numbers from 1 to 1,000, how many 5s are there? Well, every fifth number is a 5, so 1,000 divided by 5 is 200. So in other words, that's going to be, and this is going to cover this is going to cover 5, 10, 15, 20, 25, all the way up to whatever, well, actually, I guess in this case, all the way up to let's say 995 and then 1,000. Okay, but so that would tell me there are 200 5s. However, there's more than that, because notice that 25 contains two factors of 5. See what I'm saying? So every 25th number is going to have an extra 5, so I have to add that on. So that's 40 extra. So this is gonna be for 25 and 50 and 75, dot. Those should be comments there. Sorry about that. Period. There should be comments. Okay. And again, and I guess, well, in this case, it's going to go all the way up to whatever. You get the point, as far as it goes. But what about every 125 is 5 to the third power? So every 125 is going to be an additional 5 factor of 5. So that's going to count for numbers like let's say 125 and 250. And there's going to be 8 of those. And now 1,000 divided by 625 is 1.6. Now 625 is 5 to the fourth power. So there's another power of 4. There's only one number. There's really only one number between 1 and 1,000. That's a multiple of 625. That is 625 itself. So now, if you notice, I have 1.6. Well, you just go down to the 1. You round down. You don't round to the nearest whole number. You round down, because there's only one time that 625 appears between 1 and 1,000. Well, if I add up 200 for every fifth number, 40 for every 25th number, which has that extra factor, 8 for every 125th number, which has that extra factor, and 1 for every 625th number, which has an extra factor, I get 248, and 1 is 249. So there are 249, well, I'm going to say factors of 2. Hence, factors of 5, hence 249 zeros. I meant to write 5 there. Now, what about are there that, but I need for every factor of 5, that's not enough. I need a factor of 2. Well, are there going to be at least 249 factors of 2? Well, that's a slam dunk, because since every other number is even, that's right away 500 factors of 2. So really 2 to the, oh, that's an interesting way of putting it here. I just want to write it here. Another way of putting this is that 5 to the 249th is a factor. It's a good way of putting it. Of factorial. Now there's a lot of factors of 2, so way more than I need to answer this question. So that's it. That's really I'm limited here by the number of amount of 5s I have. Now, if you notice this notation over here, I have these brackets here. Now these brackets here is something called the greatest integer function. The greatest integer of n, it means the greatest integer less or equal to n. Now 1,000 divided by 5, we said that's 200. 1,000 divided by 25 is 40. 1,000 divided by 125 is just 8. But 1,000 divided by 625, that's 1.6, and the greatest integer less than 1.6 is 1. Now, if I go to the next power of 5, which is 3,125, well, 1,000 divided by 3,100, that's less than 1. The greatest integer is 0. And I could really, technically, I'm going to add these forever because they're all just a bunch of zeros. I have 1,000 divided by 5 to the 4th power, a 5th power, 1,000 divided by 5 to the 6th power, 1,000 divided by 5, because the greatest integer is just zeros. We're just adding zeros forever. That's why the formula is as it is. That's why the formula winds up being n over p, the greatest integer in n divided by, so n is my original number, the greatest integer is n over p plus the greatest integer in n over p squared plus the greatest integer in n over p cubed plus ... forever. And I could do this infinitely. Now, why am I doing it infinitely if it's just supposed to be a finite answer? Well, because eventually they all just become zeros. Once I get to the first power of p, which is bigger than my original number n, then they're all just going to be zeros. So that really is that. Let's see, there was something else. Let's see, I'm not done yet. Here we had an example that wanted to find the greatest, let's see, let's look at the question here. Let's look at 112, question number 2. Find the highest power of 72 contained in 1,000. Now, 72, as you know, is 2 to the third and 3 to the second times 3 to the second. So I got to figure out which is there more of, which is there less of. Whichever is the lesser one, that's what we're going to be limited by. So let's take a look here. So if we look at 1,000 divided by 2 is 500, divided by 4 is 250, 125, 62. Again, greatest integer. It's really 62.5, but it's greatest integer. 31, 15, 7, 3, 1. And then from that point on, once I hit 1,000 over, it's all zeros. So if you add up all these numbers, 500, 250, 125, so on and so forth, 62, 31, 15, 7, 3, 1, you get 994. Okay, now so 2 to the 994 is a factor of 1,000 factorial, but I need 2 to the third. How many 2 to the third? How many 8s are there? Well, I have to take 994 and divide it by 3 because 8 is 2 to the third power. and that's 331. So the highest power of 8 that goes into 1,000 factorial is 331. Now we have to see what's the highest factor of 9, and really whichever is the lower one is going to limit us. So the highest factor of 9, we're over here. So if I do this similar thing with 3s, I get, let's see, 994 divided by, oh, so sorry, 1,000 divided by, let me just write over here. What is the highest power of 3? So 1,000 divided by 3 is 333. Divided by 9 is 9111. Again, we'll talk about the greatest integer less than that. So that's why I have all exact answers. Then 37, 12, 4, 1. And then after that point, once I get higher than 729, then it's all numbers less than 1. So it's just adding a bunch of zeros. Anyway, if you add this up, 333, 1, you get 3 to the 498th power, but I want powers of 9. 9 is 3 squared, so I have to divide this by 2, and that gives me 249. So the highest power of 9 is 249. So I have 249 here, and let me just highlight that. And let's see. Oh, what was this in color? Red berry. Light red berry. Let's try that. So the highest power of 9 is 249. So the highest power of 8 is so the highest power of 8 is 331. The highest power of 9 is 249, but I'm limited by whichever is lesser. So the highest power of 72 is going to be 249, which means that 72, oh, I don't know what that. It's just, which means that 72 to the 249th power, 249 power, is a factor of 1,000 factorial. And that's kind of cool and awesome. That's how it works. Anyway, that's section 1.12. Hope you enjoyed it as much as I did. And we'll see you guys next time. Bye, everybody. It's been a lot of fun. Bye.